My board's a little bit off. Okay, so let's talk domain. I just threw some pages with notes out there to remind you what a function is and to take a look at these things. We're going to deal a lot with domains over the course of this pre-calc honors. You kind of touched a lot of it. Is that algebra 2 Common Core goes more to domain than regular algebra 2 does. So you're kind of at a better advantage than the kids in the past have been. Domain are all possible x values. You guys just grab one of each of those things, please. My board. And the range is all possible y values. Normally, we look at things over all real numbers. Everything is real numbers, except for when we get into using the quadratic formula, we'll use imaginary numbers. Because that's the only place we really need to use an imaginary number, is when under that square root we get a negative number. So we only do one little section with imaginary. Everything else we're understood to do real numbers. Now sometimes it will say under the domain of integers, under the domain of rational. So just grab one of each of those, okay? So just watch where your domain goes. Sometimes we'll do little examples where your domain kind of cuts off a little bit. And we'll start it, stop it, start it. If we have domain restrictions, tomorrow we're going to look at your 3 major domain restrictions. If we have domain restrictions, we find the restricted number and we remove it from your allowable domain. So our domain is still going to be defining all our x values. And our range will define all our y values. We know the difference between a function and a relation. What's the difference between a function and a relation? What's a relation? Two things, go ahead.
Two things relate to each other.
Two things relate to each other. Yeah, is there any rhyme or reason to it? Nope. They could be related anyway. What does a function mean? Okay, so if I have one domain, one set of numbers, let's make this better. This is a relation. Two numbers just related. Make a couple of points here and excuse me, here and there. Is this a function? No, because what? What repeats? The y repeats, so 1x, 2. Okay. So think about this for a second. Let me graph this. 1, 1, 2, 3, 4, 5, 6, 1. Think about this for a second. The y is repeating. I get that. Is it a function? What other way do you know to tell a function? A vertical line test. Does it pass the vertical line test? So is this particular set a function? The y repeats. I get that. But is it a function? What cannot repeat? Yes. Guys, just grab one of each of those if you don't mind. Because the y repeats, what is this not? A one-to-one. It's not a one-to-one, but it is a function. To make this not a function, I have to make my x repeat. Say I did this. Okay, now I'm not a function because 1, 1, 1, 3. Okay. Now, God bless you. Going back to these sets, your domain, God bless you. Your domain in these sets of numbers are discrete. Did you guys learn discrete? Okay, discrete means just those numbers. And they're generally whole numbers. It's a finite set of numbers. In other words, I'm not all real numbers for my domain. My domain would be all my x values. 1, 2, 4, and for this guy, 6. Okay. All my x values. Whole numbers, discrete, they're finite numbers. If I have something continuous, it usually goes from 1 to 5. And maybe I have a line that goes like this. So now my domain will be continuous from 1 to 5 because I can include all the numbers in between. So now my domain is going to be 1. You guys write intervals like this? Okay. You can do it this way, but we kind of stick to the interval notation. If you have trouble with it and you do this first and then get to your interval. Eventually, we just do all intervals. I find it easier just for intervals anyway, but whatever you're used to, will convert you over. So when we look at this, these are more discrete values. These are continuous values. Is this guy a function? Is this one a one-to-one? Yes, because what? It passes a horizontal line test. We don't do ontos in here, and I really don't know why we do ontos ever, but it's weird thing. I was doing summer school, and one of the Apex kids was doing an algebra 2, and I don't know, did you learn many ontos?
I
have no idea what a many onto is. An onto is when every element of the domain is attached to every element in the y in the range. It just goes like a 1-for-1. Everything is used up. In other words, a line is an onto. It uses every element of x, every element of y. But they had a multiple choice question, and it said many onto. So I said, well, we don't have such a thing, many ontos, and that was the answer. I have no idea what that meant. But I'm like, Apex does weird things. It gives it its own definitions that you have to read and then answer their questions. But we don't even do ontos. We just do one-to-ones and functions. When we do one-to-one, we do inverses. And we do a lot with inverses in here. We do inverses for functions, for rational functions, for trig. We do a lot of trig. We do trig inverses. We do a lot of inverses in this. Logs, inverses of exponents. So you'll kind of see these. Today is just kind of a review of let's make sure everybody's on the same page. And then oh, now my thing is all the way over here. They told me this was working, but apparently not really. Okay. Again, your values of x. Your real numbers are all continuous. Tomorrow we'll worry about domain restrictions. Domain restrictions come from a denominator can't be 0, under a radical can't be negative. We have 3 major domain restrictions. Tomorrow we'll deal with those because we see those all the way through precalc, and you probably saw those through algebra 2 as well. There's really 3. A denominator, under a radical, and a radical under a denominator. There's only 3, and I'm pretty sure you started them in the Common Core, right? Kind of? Okay. Did you set this equal to 0 and then remove it from your domain? Did you do this?
Yeah.
Okay. Common Core did a lot more with domains. The reason I'm asking, you're the first group that's coming through Common Core. So I taught algebra 2 quite a few years ago, but now Common Core does it a little bit differently, which is better for our pre-calc kids. You actually will understand a lot of the things that we do in pre-calc because you had exposure to it in algebra 2. Okay, so our domain.
Good morning. Today is Wednesday, September 07, and it is a B day. All classes should be at level 0 at this time. Will everyone please stand for the pledge? I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. Please remain standing for a moment of silence. Thank you. Please be seated. Good morning and welcome back to day 2. I know that it is 25 after. Eventually, these morning announcements will begin at 10 after. Once we get accustomed to the students arriving and getting them in through the security lines and into classes. Students, please cooperate and quickly get to your first period class in the morning upon arrival. Electronic devices should have been put away and should not be seen. Those include earbuds and or headphones. If we see them dangling from your shirt or your pocket, they will be confiscated. Put them away, they should not be seen. We are also not responsible for lost or stolen cell phones or electronic devices. Dress code. Young ladies, in the next couple of days, you will have grade level assemblies. We will discuss the dress code. If your bellies are showing and you're wearing a shirt that is too short, we're going to call your parents and they're going to need to bring you a change of clothes. You will not remain in the building dressed like that. Gentlemen, pants. Pants must be worn at the waist. Anything that is sagging, we're going to ask you to pick up. If it continues to be a chronic problem, you too will be sent home dressed inappropriately. Make sure that you are dressed appropriately for school. IDs. All students must present their IDs to security upon entering the building. If you have lost and would like to order a new one, the fee is $1 and you must go to security and order it. Once they are printed, you can pick them up in the student store during your lunch period. Lunch. To all students, lunch is free this year. It's free to all NFA students. When you are in the cafeteria during your assigned lunch, step up and get your free lunch. The guidance office is closed. Please do not send students down. Only students who have been called down by their guidance counselor or who have had an appointment with them to meet. Otherwise, please do not come to the guidance office. Grade level assemblies will begin today. Students should arrive at your classes first, and then we will come on and make an announcement to have them escorted down to the auditorium. This morning, period 2, freshmen will meet in the auditorium after they've assembled in their classes. And remember that at NFA, we pledge to be on time to school and class, be prepared and engaged, be respectful of ourselves, others, and our school. That's all for today's announcements. We're at NFA. Our mission is inspiring students to become tomorrow's leaders beyond Academy Field. Let's have a great day at school today.
Is your assembly tomorrow? Period 2. Period 2 tomorrow. Okay. All right, so again, just a little bit of a review. I threw some things in here. Your X is called your independent, your Y is called your dependent variable. And when we talk about the value of a function, very important when we say the value of this function, we're talking about the Y value. Because we give the X, we get the Y value in return. So sometimes you'll just see them ask for something about the value of the function. So know that they're asking about the Y value. Okay, again, a discrete set versus a continuous set. It's kind of to bring you on all the same page with the domains. That you guys probably know all this stuff. Can you all graph and figure out your domains when you graph? Right? Okay. An easy way on your graph is to look at your table and see if there's any errors. That tells you you have a restriction if you can't find it. So then you can look further. We also do graphs in here where we call it a point of discontinuity. It looks like it's a line, but there's one little point that you can't see until you look at your table. So we do things like that in here. It's actually pretty cool. Once we get into our functions, more with the functions, it's actually pretty good what we can do. We can do so much of this without your calculator. The range, the domain, and everything else here. Parabolas, we do a lot with parabolas. Parabolas generally have no domain restrictions. Just like a little blurb on domains. We spend so much time looking at domains in this course. I honestly don't know what's wrong with my board. Okay, and again, interval notation. We try to use interval notation. So just remember just how to write your interval notation. Your bracket includes the number. Your parentheses does not include the number. We use a U to join the parts of the domain. Say my domain goes from -5 to -3, and then it jumps over here to 2, and it's open, and it goes to, okay, say it goes to 4, and that's open. We'll start like this. We'll go -5, -3, jump over it, and to 4. Did I do this last year? No. You did this where? A couple years ago? Wow.
Yeah, I think we did in like 8th grade.
Really? Oh, very good. Good.
We just wrote it like in the, not interval set.
Set notation.
Yeah.
We said X such that,
But like the ones where you have to do it, there's like 4.
and then we'll go to or statement. Yes. Yeah. Yeah, like a compound inequality.
Yeah.
Yeah. Yeah, I see what you're saying there. So we're kind of moving towards this. Here's one with an or statement in it. So if I was to, and here's my and statement, and here's my or. So just so that we're all on the same page, when we do a number line in here also, don't fill out your whole number line. So if you put a number line for this guy, here's your -3, this is all I need to see. I don't need to see the rest of the number line. Don't put the 0 there, because what happens is we do a lot where we test intervals and see who's positive, who's negative, where the domain and the range actually fall. So if you put your 0, it's going to look like it's another interval. So just give me your critical, call these, I'm going to call them a critical value. When it cuts off part of your number line, we're going to refer to it as a critical value. So we find our zeros, those become our critical values. We put our parabola through it, we see where it's greater than. You did inequalities for quadratics, right? Like say you did y is greater than x squared. Did you do these inequalities for quadratics? So maybe. Okay. So we'll work on those. But for us, we want to get our interval notation down. Always read left to right. So this guy is going to say -∞ to -3. The infinity always has a soft parentheses because there's always one more. Okay. This one, again, if you make a number line, all I need is the 4. Put it open, put an arrow. So we're going to say 4, soft parentheses, to infinity. And these guys, I just need the -3. These are your critical values. It's closed at the -3, opened at the 2, it's an and. So it goes in between. So you're going to give me a -3, hard bracket, to 2, a soft bracket. And you're going to see a lot of intervals that are mixed. One end might have a hard bracket, one end might have a soft bracket. This guy, I'll write this up here because I know it's hard to see down there. Okay, so this one is going to say, all I want is your critical values again. So it's going to look like this if we wrote it with on a number line. And this is your or statement. This is where we're going to use the U. So we're going to say -∞ to 7 or 10 to infinity. We kind of just jump over it. And we're going to use that U a lot this year. What happens is we get a lot of domain restrictions. So there's parts of your domain that we can't use. We do a lot. Did you do anything with asymptotes last year? Good, because my regular algebra teams didn't do asymptotes. An asymptote is something where you have a domain restriction. So say we did 1 over x plus 1. X, yeah, x plus 1. So you can't use a -1. So at -1, you kind of have this thing that goes like this. and an asymptote. Some did, some didn't. Probably. Yes, one of the famous ones, yes, it goes like this. Yeah. That's because your asymptotes are at your axes, a y equals 0 and x equals 0. That's also like an inverse one. Who did you guys have last year? DiCaprio. Baker. Anybody else? Imperiale? Imperiale probably did the most with this, right? You guys pretty much know what you're doing? Imperiale, she's been teaching for a long time, and I know she stressed Common Core. Because she followed the Common Core through geometry into Algebra 2. See, it's hard sometimes. As a teacher, I've taught Algebra 1 for years, Math A, Math B, and I had all the Math A kids, and then I knew what Math B was getting, and then I did precalc, I knew what precalc was getting. But with Common Core, I don't teach the under ones anymore, so sometimes now with Common Core, I'm gonna ask you guys a lot, did you do this last year? Because some of you will have done it with some of your teachers. Some were converting over, some were doing, whatever they could fit in there. So usually what happens with a new math is it takes a couple of years for everybody to get on board. I do like the Common Core concept, but you really have to follow. You guys were at a disadvantage starting in algebra. It really had to be earlier than your algebra, because you would have seen a bigger difference. It really is not a bad concept. I have 2 grandchildren that live in Pine Bush District, and the youngest one, started in like 2nd or 3rd grade. He's now in 7th grade, and he's great when it comes to math. He'll even tell me when I go over there and I help them, he'll tell me, when you do a ratio, you set a little label up. You say like miles per hour, feet per whatever you're doing, inches per whatever you're converting. He says, no, Grandma Ray, we don't do this anymore. We do an algorithm. An algorithm in 5th grade. I'm like, wow. But I think he has a better concept of when he does something. He'll get a picture, and it'll show this, and it'll give them certain things, and he has to do, God bless you, he has to figure out how much wire is needed, which is all the outsides here without this piece down here. I think he has a better concept, a better grasp than my older grandson. That he was immersed into Common Core in 8th grade. So he was kind of like you. You guys were immersed in 9th grade, right? Is that what you? Oh, 8th grade? Oh, so you're the same as my older grandson. 11th grade. Yeah. So, I think the younger one has a better feel for this. He actually understands what these values mean to him. So, and I think you guys have a better feel for what different kids had, because some of our kids were just, they made no sense out of their numbers. They would give me an answer about an elevation, and it would have a negative number. So we didn't have a crater, we had a elevation. So how do you get this? Even on the regions, some kids will come up with negative angles. How do you come up with a negative angle in your triangle? Obviously, either you forgot your calculator was in radians, or maybe you didn't do the right function, but they didn't bother to check. But I think you guys have a better concept. I think if anything else, Common Core is designed to make you get a better feeling for your math, which I kind of think is important. I always tell my students, step back and look at your answer. Is it feasible? And sometimes on the test, I get a little sarcastic. I'll say, is this really feasible? Can you really possibly have made this much money in this amount of time? They'll do an interest problem and make like millions of dollars. Really? But because they don't move their decimal point. If it's 5%, they multiply by 5 rather than 0.05. But that's a big number. You just made a lot of money in a short amount of time. You got to kind of think about it. So, I think Common Core is designed to pull that part in, to make you have a better understanding. So I hope not to bug you asking you, did you do it, did you not? And at one point, it won't make a difference because you'll all be on board here and we'll all be doing it together. In the past, especially my pre-calc regular kids, they work really hard. They may not have a very good skill base. They may not remember certain things. But when they come to pre-calc, in the beginning, a lot of it's a little bit review. We're going over equations and they struggle. Oh, I hated these fractions. I hated finding common denominators. But as soon as we get into the function part, everybody was kind of on the same page. And they really, really liked it. And they were amazed all the graphs we could do without a calculator. Because they actually have meaning to you now. You find the domain, you find the range, you find your restrictions, you know there's an asymptote, you know where it's increasing, where it's decreasing. And I think you guys will have a better feel for that. Because you kind of did a little bit of that. So it'll be a kind of trial and error with me as well going through this with you. Because you guys will be more on board. And if you're not, you believe me, you'll get on board. Okay. So now there's another part to that. Did I give you the other part? Nope. God bless you. Yes. Thank you. Oh, for the lines outside? I heard the storyline out to the street yesterday. Yeah. But I think the hallways are worse. I was having to say yesterday. Last year they came forever to get longer.
This is more.
Oh, okay. You guys have watched things. Does anybody have this sheet?
Oh, yeah.
At the end is fine. Okay. So we're going to spend just a little bit of time finding a domain and a range. You did piecewise functions, right? Yeah. Okay, so this is kind of like a piecewise function. I'm not asking for the equation. I'm just asking for a domain and range. Thank you. All right, so when we look at this, and you probably hopefully can see it a little bit better on yours, it's important that we note that this is a function, that if we dropped a vertical line, this one's closed, this one's open. So it is a function. What would my domain be for this? If I'm looking at every x value to see if it has a y. So if you pick an x value, does it have a y? These guys all have y's. This one, does it have a y? Good. So what's my domain for this? Good. All real numbers. Good. How about my range? Use your y as a number line. Kind of go like this. Do these all have y's? These keep on going forever and ever. And then these guys kick in. They all have y's, right? Where does it stop? -4. Can I use -4? No, because is this open on yours? Mm-hmm. Yeah. So it's open, right? Meaning I can't use -4, but I can use -4.0000, -3.9999999 I can use, but I can't use -4. So I'm starting at -4, open, and going to infinity. Okay. So when we look at number 2, first of all, is it a function? Mm-hmm. It passes the vertical line test. I'm sorry, it's probably hard to see up here, but on yours it should look a little bit better. This does pass a vertical line test, and every x I'm looking for has a y. So again, my domain, this one has a y, it's all real numbers. Use your axis like a number line. My y's. My y's say, okay, I've got a y here, a y here, a y here, a y here, but nothing down here. So what would be my range? 0 to infinity. And would my 0 have a hard bracket or a soft bracket? A soft bracket, because this guy's an open circle. Good. Try the next two. Work on the next two. So what would be your domain for number 3? Negative infinity to infinity. Every x, I can find a y to. Okay, and this guy is closed. How about your range? Good. 3, hard bracket or soft bracket? Soft. Good. Because it has the open circle. Good. How about 4? What's the domain for 4? Good. And your range? Again, negative infinity, because this is where you're going to stop. Sometimes it's easy if you box it in like this and say that's as high as I'm going to go. I'm coming from negative infinity. I'm going to stop at 3. And this time, I can use 3. Okay, try the next bit. You're doing good. What's the domain for number 5? Good. We're kind of seeing that, right? Because this is a function because one is open, does it look that way on yours, and one is closed. How about your range? 0. Good. Everybody's getting this? Number 6, your domain. Okay. And your range. Okay, so here's our cutoff. We can't use anything down here. We're going to start here and use everything up here. So -2 to infinity. Good. How about number 7, domain? All real numbers. Good. Negative infinity to infinity. And your range? All real numbers again, right? Because all of these get used down here. That goes on forever. All of these go on forever up there. So all real numbers. Okay, so how about this guy? What's the domain? And the range? -2 to infinity. Hard bracket or soft bracket? Hard bracket. What if I did this? I had this guy stop. I know it's kind of fun to do that, but what if I did this? If I stop this right here, what would my domain be? -infinity to 3. Good. Would it change my range? Yes. What would my range be? -2 to 2. Hard or soft? Hard, yes, I made this hard. Then 4 to infinity. Oops. Doesn't like this side. Then 4 to infinity. Everybody see that one? I changed the original one. Okay, so everybody's okay with these? Alright, I know you have 2 more, but that's okay. Alright, just a little homework. Have you look at functions and domains? Yes, take your homework. Give you much time. Okay. See you guys tomorrow.
I just underlined.
Then I'll hand it to your guy.
Oh, I need to get my sign.
They probably will just do it. Huh?
Sit next to the